This is an inequality, and of course I will multiply everything by 10 because 10 is the least common denominator. So we can do it on the side. Negative 1 over 5 times 10 over 1, you simplify by 5 and you get negative 2. So this is negative 2x. Then you multiply negative 2 by 10 and you get negative 20. Again, take it on the side. 10 over 1 times 3 over 2. You simplify by 2 and you get 15. So this is 15x minus. You multiply by 10 and you get 50x. Do you agree with this step? Mm-hmm. So we multiply both sides by 10. It's not negative 10. I'm not saying that you multiply by negative 10. We multiply by 10 and we do not switch the symbol of the inequality because we multiply by a positive number. The left-hand side is still negative 2x minus 20, but here I will definitely combine like terms. So 15 minus 50, I know that 50 is stronger, so it's going to be negative. So 50 minus 15 is 35x. Good. At this point, I move this to the other side. I keep negative 20. I have to be very careful now. So when I move the positive 2x, this becomes negative 33x. I recommend rewrite the inequality first. Negative 33x less than or equal to negative 20. And then divide both sides by negative 33. Negative 20 divided by negative 33 is a positive number. But now, flip the sign. So the interval notation will be x in which side? Where do I go? Where is the starting point? Say it again. Very good. Infinities will never be brackets. Comma? Very good. This is it.
Can you skip a test in any class to prevent my grade going any lower than it is probably now?
Skipping a test gives you a 0.
Quiz.
Oh, skipping a quiz will not affect your grade. Skipping 10 of them, it will. Okay, any questions on this? Any questions on this? Okay, so now let's go back to the end of chapter 2 and let's review. I'm ready for your questions. When you look at the review for chapter 2, starting on page 162 through 165, 160 through 165, tell me what would you like to review. We reviewed last time. We did a lot of problems from everything, but if you still need to work on something, for example, 73 caught my eye on page 164. The number 137.5 is 125% of what number? So please tell me what to write. 137.5 is
137.5 equals 0.12.
exactly of x. Very good. Excellent. Great. Great. So then how do I get x?
125x by multiplying.
137.5 divided by 1.25. And I'm lazy. 137 0.5 divided by 1.25, and I got 110. X equals 110. Is there anything else that catches your eye?
85.
85. In 2005, so this is 85 on page 164. In 2005, Lance Armstrong, wow, well, incredibly won his 7th Tour de France. Well, the first man in history to win more than 5. Suppose he rides a bicycle up a category 2, climb at 10 kilometers an hour and rides down the same distance at a speed of 50. So he goes from this point to this point, from A to B, at 10 kilometers an hour, going this way, and rides down the same distance, come back from B to A this time, at a speed of 50 kilometers per hour. Okay? Find the distance traveled if the total time on the mountain was 3 hours. Very good pick. Thank you. Okay? So he goes from point A to point B at 10 kilometers an hour speed. Yes, please. Yes. Rate times time. Yes. Distance equals rate times time. But let me allow me a second to explain the problem. So he goes up from point A to point B. The speed is 10 kilometers per hour. Then he comes back from point B to point A, same identical distance, but at 50 kilometers per hour because he's going downhill, right? So his speed is much higher. Perfect. Now we know that from A to B plus time from A to B plus the time from B to A is, they say, 3 hours. So I have to write that down as well. Total time, 3 hours. From A to B and return. So now the question is, find the total distance traveled if the total time is 3 hours. So we don't know the distance between A and B, and the back is the same, B to A. So these are two entirely different scenarios. When he goes up, his speed is 10. When he comes back, his speed is 50. So we cannot combine these two scenarios. Maybe he goes up today and comes back tomorrow. He takes a break. All we know is that the total time from A to B and then plus from B to A is 3 hours. So you cannot combine these two situations. They do have something in common, but you cannot say 3 hours and 50 plus 10 or something like that. No, you cannot combine them. So we have to find or write an equation for the first scenario going up. Then we have to write another equation for the second scenario going back. Now, what do I know? I know the speed up and down. I don't know how long it takes him to go from A to B going up. And I have no clue how long it takes him to come back from B to A. All I know is that he goes up in blah hours, plus he goes down in whatever number of hours, and the total is 3. That's all I know. So how many variables does the equation have? So, well, I will say 3. First of all, I don't know the distance. That's one thing. I have no clue about the distance, and that's the question. What is the second variable?
The amount of time it takes him to get up the hill.
Right. What is the third variable? Nick? Coming back, right? The time needed. Okay. So let's see how we do this. 3 variables. Wow.
What do it say? So what? For the third one?
The third variable? Yeah, this is 3 hours. Total time 3 hours.
No. Where it says for.
So from A to B, 10 kilometers an hour as speed. From B to A, 50 kilometers an hour. Good. So then I need how many variables? 3 variables. So here they are. D is the distance. Let's call X time going up. Let's say Y. We normally denote them by T1 and T2, but we are used to X and Y. That's the same thing. It doesn't matter. And time going down. So I need how many equations again? I'm ready. We will use the same type of manipulation to get rid of 2 of them so we can solve. We only know how to solve an equation with 1 variable. But we will be able to get rid of 2 of them. So
will you add the rate?
I'm not combining them. Don't even look. This does not exist. I'm only telling you that I go up the hill between point A and point B at 10 miles an hour, and I have a distance of D and the time of X.
So 10x.
Say it again.
10x. D equals 10x.
D equals 10x. The first one is done. Moving on to the second one, forget about the first scenario. It's gone. Say it again.
Y equals 50x.
Careful. Distance
D
equals rate times time.
D equals 50y.
Very good. So I'm done with the scenarios, and now I'm also told that the total time is 3 hours. Look at the variables, the way we define them. Yes. No. Yes. Shane?
The 10x plus 50y equals
10x is kilometers.
that's okay.
50y is kilometers. I cannot add kilometers to kilometers and get hours,
Okay.
right? So all equations, always keep that in mind, all equations have to be consistent. Ounces of pure gold plus ounces of pure gold equals ounces of pure gold. Time plus time equals time. Distance plus distance equals distance. So what do I write?
You add the 2 distances?
Not yet. I can't add the distances because I will not get anything.
So is it 10x plus 50y?
I cannot.
D equals 10 times
I cannot. So going up, D equals 10x. Coming down, D equals 50y. Time, 3 hours.
So can we figure out his time spent doing each for 3 hours?
Not yet. I have to use 3. I have not used 3, and I cannot use 10x plus 50y because that's distance plus distance equals hours.
10 times 3.
But 10 is going up. 3 is not going up,
That's that number of hours.
but it's not going up.
Okay, so if he spent 3 hours pedaling at 10 kilometers per hour,
No, he
that wouldn't
didn't.
give us a
No.
distance there.
No. So the amount of time needed to go up is totally unknown. We denoted it by X. The amount of time coming back down is totally unknown.
Mhm.
And it's Y.
But we were told that it was equidistant, right?
No, time cannot equal distance.
No, I mean, like, it was the same amount of time spent doing each, right?
No.
Or is it the same distance spent doing each?
Ah.
Would it equal X, would it be X plus Y equals 3?
Absolutely. X plus Y must equal 3 hours. The time needed to go up, say it again. You said the same. But this is important. I can continue if this is not done like correctly. So now what do you think we should do? So here we have two options. One option is we set these two equal to each other because it's the same distance. And we create a new system. So 10x equals 50y, and we create a new system with this, which we know how to solve because we've done that a long time, many times. Now, before we do this, do we understand the three equations? Are they clear? Yes? That's the most important thing. Are they clear? Perfect. So the distance going up is 10 times x. The distance coming back is the same distance, d equals 50y. But the time needed to go up plus the time needed to come down must equal 3 hours. Good. So now what? I set these two equal to each other by using substitution. So 10x was replaced d. So I have 10x equals 50y and x plus y equals 3. So now, what would you recommend? Yes, please. Shane?
You would divide 10x by 10?
Yeah, I agree. So then I have x equals 5y, excellent, and x plus y equals 3. I can divide both sides of an equation by 10. I'm allowed to do that anytime. And I should do it to simplify everything. Good. What now? Replace this x by, excellent. So 5y plus y equals 3, 6y equals 3. How much is y the time he needed to come down from A to B? 3 divided by 6 is 1/2, or 30 minutes. So 1/2 of an hour. I have to keep it in hours because the speed is given in kilometers per hour. So he needed to come back down from B to A in half an hour. If the total trip was 3 hours, how much he needed to go up from A to B? 2.5. So then x must be 2.5 hours if y is 0.5. But we are not asked to find x. We're not asked to find y. Actually, the problem is asking us to find the distance. Okay, let's find the distance. How much is the distance? From the first equation, how much will the distance be? 10 multiplied by 2.5 is a measurement unit. Thank you. Let's check with the second one. What should the second one give us? What should I get from the second equation when I plug in y?
25.
Of course. That's how we started, by setting the two distances equal to each other. But I still have to go back and check in all of them. So when I plug in x, I get d 25. When I plug in y, which is 0.5, I get d equals 25. And then 2.5 plus 0.5 is 3. Everything checks. So this was a system with 3 variables.
Where did you get 25 kilometers from?
2.5 times 10 is 25. 50 times 0.5 is 25. Good, very good pick. Anything else catches your eye between 1 and 102? Anything? Anything? 47. 47. Very good pick. 47. So 0.5 quantity 2n minus 3 minus 0.1 equals 0.4 quantity 6 plus 2n. So this is problem 47 on page 163. So let's work on this for a minute. Ready? Can anyone dictate? No one wants to? Okay, 0.5 times 2 is 1, times n is n. 0.5 times negative 3 is 1.5 minus 0.1 equals 2.4 plus 0.8 n. Very good. Combine like terms. N minus 1.6 equals 2.4 plus 0.8 n. I move 0.8 to the other side. From $1, I subtract 80 cents. So I get 0.2 n. And then when I add 1.6, I get 4. Final step, n equals 4 over 0.2. Or 40 divided by 2. So n equals? Very good. Anything else?
Yeah, that way too fast.
Okay. So 0.5 times 2 is 1. 0.5 times negative 3 is negative 1.5. And I copy this. 0.4 times 6 is 2.4. And 0.4 times 2n is this. Is this step clear? Then negative 1.5 minus 0.1 is negative 1.6. So I copied n and then negative 1.6. I copied 2.4 and I copied this. So far so good? Say it again. Moving up?
Just move it up.
Oh yeah, I couldn't hear. Sorry. So then I move 0.8 to the other side, subtracting 1 n minus 0.8 n is 0.2 n. When I move 1.6 to the other side, 2.4 plus 1.6 is 4. And then I divide both sides by 0.2 to get 20. Is this better?
What, round 1.6?
Say it again.
Round 1.6?
I'm adding 1.6 to both sides.
Oh.
2.4 plus 1.6 is 4. Any questions on this problem? Any questions?
The answer is 25.
Yes. Anything else catches your eye? Say it again. 78. The ACT assessment is a college entrance exam taken by about 60% of college-bound students. The national average score was 20.7 in 1993 and rose to 21 in 2008. Find the percent increase. Excellent problem. Thank you for picking that. Very good. Ooh, it's 5. Page 5. Okay, so we picked problem 78 on page 164. The national average score, 20.7 in 1993, so average score. And 21, average score was 21 in 2008. Find the percent increase. Find the percent increase. Very good. Let's discuss this. Perfect pick. Thank you.
You're only looking for one variable, and that's the percentage increase. That's what I know.
Okay, so let me just explain one thing before you say anything. Change over the original. What is the change? From score of 21 minus 20.7, and what was the original? The initial, the first score that was recorded in our problem anyway.
20.7.
20.7. This will give us the percent increase. The change over the original. So the change 21 minus 20.7 is 0.3 divided by 20.7. And when you divide 0.3 by 20.7, you will get 0.0144. I'm going to write 0.01449. So in percent, this number is, I have to move the decimal point how many units and where? To the right, how many? 2. So this is 1.45 approximately percent.
Sorry, can you repeat why you moved number 2 times?
Oh, because I have to give the answer in percent. The question was, find the percent increase.
Or you can multiply it by 10. I mean 100.
I cannot multiply. I have
What do you
to.
mean by a percent?
So I cannot multiply. I can multiply and divide, but I cannot just multiply. Because if I have $10 in my pocket, I'm going to say, oh, let me multiply by 100. No, I can't. It's not going to.
That's how you get this.
Yes. So let's do this again if there is any confusion. So if I have 0.33, this is the same with 33%. I move the decimal point 2 units to the right. Now if I have 20%, then I have 20 and I move the decimal point 2 to the left, and this is 0.20. What if I have 1.33? What will that be? 133%. What if I have 88%? What will that be? 0.88. What if I have 3%? What will that be? 0.03. What if I have 0.0001? Yes, so I have to move the decimal point 0.01%. So from percent, I move the decimal point to the left 2. From a decimal number, I move the decimal point right 2.
How did you know to change over and over?
Okay, very good.
It used 20.7 twice.
Say it again.
It looks like you used 20.7 twice, unless I'm missing something, which I probably am.
The change is from 20.7 to 21. So 21 minus 20.7 is the change,
Yeah.
the increase from 1993 to 2008. So that's the change divided by the original. That's the way a percent increase or decrease is calculated. The change over the original.
Can you move it up?
Okay? Is there anything else that catches your eye?
I have another question.
Yes?
Oh, I think I think
You got 1.45. Now, did you get that because the original decimal point was rounded to 9?
Because I had 449. So the 9 brings the 4 up to a 5. Anything else?
So that's the same thing for decrease too?
Yes, let's do 83. I was just looking for one. If a price decreases from 250, it decreases to 170. What is the percent decrease? What is the percent decrease?
Change over the original, right?
Exactly. Change over the original.
So it's 250 minus 175, 170
Yes,
over 250.
yes.
So that's 80 right there. So that's 80
Just
up
remember,
top.
say it again.
So that's 80 up top, right? It's gonna be 80 up top.
Okay, and then,
Divided by 100, 250.
yep, or 8 divided by 25. I got 0.32. 0.32, what does that mean?
32%.
That's it. So maybe if I should explain this. From a number to decrease to another number, the decrease is based on the original. If we go the other way, from a number going up to this number, the increase is on the original. So once we find the difference, we have to divide it by the original. So if we go up, the starting point is this. For example, let's say your salary, you're making, for the sake of the argument, $1,000 a week, a month, whatever you want. A year. A year. It doesn't matter, just one number, okay? So now you get 30% increase. So it's based on this and it goes up. If somebody for some reason goes down with its salary, so the reference point is this now. So 30% of this going up is not the same with 30% of this coming down. So always any increase is based on the original value. If you get a salary increase of 10% is on what you have right now and you go up 10%. But if you calculate the other way around, 10% coming from up, down is not going to give you the original value. So you have to be very careful. It's always the difference based on the starting point or the original. Yes, please. Eric? Yes.
Every time we do a problem, every time the price decrease, should be changed over the original. So if it's increased, is it like it's the same thing?
Yes. So the increase was from 20.7 to 21. So the change was from 21 to 20.7. There is no point in having a negative number here. So if you go up from the top to the bottom, if you go down from the top to the bottom, so it's a positive number. And you divide it by the original, whatever the original is, so that the answer will always be a positive. It has to be a positive percent. Even if you say, but the decrease should be negative. True, but it is calculated on the top anyway. And you don't calculate as a negative percent. But you could think in those terms though. Is this clear? Okay. Now, anything else that catches your eye? Or we move on. Of course, I have to start chapter 3. It will not be on the test, of course, on Monday. And I will not forget to send it. So we need to talk, Nick, what time do you want to come to the testing center to take it? So you can come to class because, again, it's not going to be a 2-hour test. So don't let me forget. Okay, any questions? Like I forgot last time. Any questions? Any questions? Is there anything else you would like to review? For the test, I cannot stress enough. You must redo all problems we did in class. All of them, right? You have to review the quizzes. You have to review your homework, and I will post homework solutions definitely by Saturday evening.
What section is the test?
All chapter 2. So test 2 is on Tuesday, and I think it's the 11th. All chapter 2. Any questions? Okay, chapter 3. In chapter 3 is a very important chapter. It deals with graphing, and for some reason, I'm not sure why, but sometimes this chapter creates problems down the road. So it may not create problem now when we talk about it, but sometimes I see people in the next students in the next course and the next course and the next course, they have difficulties with graphing. So we start this chapter and it's all about graphing. So graphing. The title is just chapter 3 graphing. So let's look at 3.1. And in 3.1 we are just looking at the coordinate system and how to plot points. So plot points first. Then we're going to look at how to read from a graph the information that the graph is giving us. Okay. So here is the Cartesian system or the coordinate system. Coordinate system. Now, this point is called the origin. This point right here. So 0, 0 is the origin of the coordinate system. Now, the x-axis goes from negative infinity to positive infinity. Negative infinity to positive infinity. Notice that we put an arrow only on the positive infinity. Now the y-axis goes from negative infinity to positive infinity, and we put an arrow on the positive infinity direction. So this line is called the x-axis. This line is called the y-axis. In a coordinate system, I can graph almost anything I can think of. In chapter 3, we are not going to graph sophisticated situations, expressions. We're going to graph only lines. So I can have vertical lines. I can have horizontal lines. I can have lines that look like this. Not like this will be going from left to right, up. This one goes from right to left, down. Okay? So, or this. This is all what we are going to graph, and just points. Now, what I need to identify before we move forward is that this, which is the x-axis, is a horizontal line. We will consider this altitude 0. This is altitude 0. Well, altitude is measured by y. Position is measured by x. So then this, because it's altitude 0, will have the equation y equals 0. if I were to graph this, can anyone give us an option of an equation like this? If I want to graph it, I'm going to graph it like a horizontal line. And can anyone give us the equation of that line? Excellent. Now, assuming I want to graph this line, can you give me an equation for this? -2. Very good. -2, -3, whatever you want. Now I want to graph a position. So what do you think this will be? It cannot be y. It doesn't measure altitude. So it has to be position. When we talk about position, we are talking about a vertical line. So what do you think the equation of this line, which is the x-axis, what will that be? Exactly, x equals 0. Now imagine that I want to graph this vertical line. What will that equation be? And I'm going to graph it right here. Can anyone give us the equation of this line? Excellent. Now, can anyone give us the equation of this line? Very good. X equals -2. So what have we established so far? We established that a line that is horizontal must have an equation that is y equals blah. We established that a line that is vertical must have the equation x equals blah. Okay? Depending on where we find that line. Agreed? Okay. Now, I would like us to plot some points. Plot points. Any point, if I want to plot a point on the coordinate system, I have to tell you two coordinates, two numbers. So I have to say, for example, 1, 1. The coordinate system is divided into 4 quadrants. 4 quadrants. And we will number them as the Greeks did a very long time ago, counterclockwise. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So 4 quadrants. Now, can anyone tell us in which quadrant both coordinates will be positive? Yes, positive and positive. Can anyone will tell us in which quadrant both coordinates are negative? Can anyone tell us what happens in the second quadrant? Which one is positive and which one is negative? So if I write an ordered pair, which one will be positive and which one will be negative? What about this? Very good, because it's on this side. And what about this? Because it's measured up. And what about the fourth quadrant? Which one will be positive and which one will be negative? The first one will be positive and the second one will be negative. Very good, excellent. So now I would like to plot 1, 1. Where will I plot 1, 1? In the first quadrant. 1 on the x-axis and 1 on the y-axis, and I find the intersection of those two. So this is 1, 1, this point. What if I want to plot 0, -3? Which quadrant would that be? And I have to be careful. If a point is either on the x-axis or on the y-axis, the point does not belong to any quadrant. One more time. If a point lies on the x-axis or on the y-axis, that point does not belong to any quadrant. So where will I plot 0 for x, negative 3 for y?
You plot it right in the middle, one in the middle.
On the Y.
On the y-axis, 3 units down. So this is 0, comma, negative 3. 0 for x, negative 3 for y. Any questions? Any questions? Okay. Now, negative 3, negative 2. Where will I plot this point?
And the twos, up on the left-hand side.
So x is negative 3. 1, 2, 3. Y is negative 2. 1, 2. And at the point of intersection of these two. Negative 3, negative 2, and that's where they... So this is in the third quadrant. Any questions? Okay. What about 4, comma 0? Where will I plot 4 for x, 0 for y?
This would be
On the x-axis at this point. 4, comma 0. Which quadrant does that belong to? None. It's on the x-axis. Very good. Now I would like to show you a graph in your book. This is on page 171. If we look at this graph and I ask you between, so this is time in minutes and this is pulse rate. If I ask you what happens to the pulse rate between 5 minutes and 15 minutes?
Starts to go down.
Yes, I agree. From which value of y? From negative 5 down to? You may not see it, it's 80. So from the height of negative 5 till the height of 80. So the graph went down. And on the x-axis, it went from 5 to 15. Any questions? This is how we read from graphs. So here's another example. What happens to this graph between 25 and 30? It's slightly going up
Yeah.
from this value of y till whatever that value of y is, but it goes slightly up. Any questions on what I just showed? Okay. I would like us to, if you have your books, on page 180. Uh, 182, I'm sorry. We're asked to complete a table. So let's complete the table. I'm going to choose 51. On page 182. We are given this equation, y equals negative x plus 2, and we are asked to complete this table. I don't like vertical tables. I prefer horizontal tables, but that's okay. I'll stick with what they give us right now. So 51. So we have x and y, and they're giving us 0, 0, negative 3. So we're asked to complete the table given the information we have. That x is 0, find y, then y is 0, find x, and then x is negative 3, find y. So let's come back to our equation. We are told that y is negative x plus 2. I'm given that x equals 2. Can anyone identify y? I'm given that x is 0. I'm sorry. Can anyone identify y? 2. Okay.
Why two?
When x is 0, 0 plus 2 is 2.
Okay, plus two.
So now we are told that x equals negative 3. How much is y? So negative 3 is 3. 3 plus 2 is 5. Now we're given that y is 0. Let's replace y by 0. 0 equals negative x plus 2. And let's move negative x to the other side. Yes.
Do it again. I just got
The opposite of negative 3 is 3. 3 plus 2 is 5. But it's minus in front. And x is negative 3. Right? This is what we studied in chapter 2 when we replaced. Be careful how you replace. You have to put parentheses, right? So if you want to write it, this is y equals negative 3 plus 2. So the opposite of negative 3 is 3. 3 plus 2 is 5. So now we are told that y is 0. Let's find x. So I have to move negative x to the other side. What do I get? So when I move negative x to the other side, I get x so 0 minus x is x equals 2. So 2. Is that okay? We don't write 0. When there is 0 on one side and we move something, then we don't need to write the 0 anywhere. Okay.
What happens to the negative though?
Which one?
It's a negative x.
So when I move a term from one side to the other, I have to change its sign. Or you write that you add x to both sides. You add x. This is gone, and you have positive x on the other side. Right? Or you remember that when we move a term from one side to the other, the only thing that happens is the sign changes. Very good. Any questions?
Are you gonna send it?
Say it again.
Are you gonna do a similar problem?
Yes, yes, of course. Would you like to choose?